Hi, so this is video number 5, and we're kind of, getting into it, we're getting into the actual core concepts. So we're going to be covering a really fundamental part of, C program, or programming in general, right? So we're going to be covering what variables are, right? So you can think of variables as sort of like little boxes in memory, right? Where you can store anything, data, usually, okay? So each of these boxes has, three significant, well, four, okay, but I'll go with three of them right now. There are more, obviously, which we'll get to later. Spoiler alert. This is going to be super important. These other properties will be super important when we learn about pointers, okay? So let's go with the three basic ones, okay? Every variable will have a name to it, okay? And every variable will have a type to it, all right? And the last thing is every variable usually has a value to it, right? So the name of a variable is what we use to sort of reference it, right? So in this case, right, we've defined a bunch of variables here, like Alice's age, okay, Bob's height, and Alice's initial, okay? So we're kind of imagining that Alice and Bob are two different people, yeah. So let's see. So in the case of this variable, Alice's age, the name of the variable is Alice's age, obviously, okay? And the type of the variable is int. So what that means is this variable called Alice's age can only store integer type data, right? So this box can only fit integer type data. And in this case, the value that's in the box is the value 30, right? So we're sort of declaring this variable called Alice like this. So we're like int Alice's age is equal to 30. So in the same line, we're both declaring Alice's age and also initializing a value of 30 to it, right? We could also do something like this. Int Alice's say, I don't know, man, height. Yeah, not height. Fingers. Why not? Okay. And I can do this. So in this case, I've only declared the variable Alice's fingers, right, as type int, but then I haven't assigned a value to it yet. So what that means is I've constructed the box and I've named the box, but I haven't put anything in it yet, right? And I can do that by doing this is equal to 10, right? So these two statements are pretty much the same thing as what happens here, right? So this is the declaration and this is the initialization, right? Okay, so that is kind of it. So, and in this case, similarly, another box, okay, Bob's height, but then we see that its type is float, right? So what is a float, right? So let's sort of go over things, right? So C has a bunch of different data types, and what a data type essentially is it's a okay, so we know that computers store data in the form of binary ones and zeros, right? So we have different methods of storing different kinds of data, okay? So in this case, int is a kind of way in which you can store whole numbers, right? Not whole as in just, 0 to whatever, like it also includes negative, but numbers without a fractional component, right? So like 5, 6, minus 10, 40, and so on, okay? So yeah, so that is what an integer type is. We also have types that are similar to it. So for example, we have like long, okay, which is just an integer, but then we can store bigger numbers. And then we have like a byte and stuff like that. But I'm gonna go with the commonly used ones, which is int, okay? And the next up we have float, right? So if I want to store the value 1.5 and I try to assign it to say an integer type, it'll just store 1. It cannot store the 0.5, right? So in the case where we want to store like decimal values, we always use a float type variable, okay? It's called a floating point, okay? Another variation of float is like double, which is the same thing as float, but with double the number of decimal places, obviously double. So yeah, pretty much very similar to, int, but then it's just instead of having whole numbers, it also holds decimal places. Then we have something called char. Okay, so char is a little different than what we're used to so far, right? So int and float have always held numbers, right? But using char, we can actually store a single like letter. It can be a letter, it can be a number, it can be a punctuation mark, it can be anything, but it's a single character, hence char. Okay. So yeah, that is another box with a different type associated with it, right? So yeah, so if you ever want to make a new variable, right? You want to initialize a new variable or you want to declare a new variable, it'll be something like the type of the variable, space, the name of the variable, and if you want to just stop at declaring, put a semicolon there. And if you want to sort of initialize it as well, you'd say equal to and then whatever value, right? So that's kind of all there is to variables, honestly. There are other concepts, like obviously different data types have different sizes in memory. And if you were to say define a variable within a code block, it is sort of restricted to that scope. But I think that's a little bit too much for now. So maybe I'll explain how variable scopes work when we discuss functions, because then that will be easier to understand then. But for the most part, this is kind of all there is to it. And you can also sort of learn how to sort of print, variables here. So in this case, we can see that this print statement looks a little different than what we were used to, right? So I think I formatted it. Why not? I have, okay. So usually when we see a print statement, it's just a string, right? But in this case, we have like a bunch of extra variables within the parentheses. What does that mean, right? If you were to pay attention to the actual string within it, you would notice that it has these things like %d and %c, right? So we use %d in the case of like integers, right? So what basically happens is whatever the first integer is over here after our string in this function called, the value of Alice's age will be sort of put where this %d is. And similarly with %c for the character variable, right? So the value of Alice's initial will be put here. And similarly for float, we use f. It does the same thing, but then, we have a little 0.2 in front. So what does that mean, you might ask, right? So since floating point values can have many decimal places, sometimes we may not want all the decimal places, right? So if we just want 2 points of precision, we put 0.2. If we want 3, we put 0.3 and so on, right? So yeah, that's kind of it, so let's compile this program and see what it prints. As you can see, it says Alice is 30 years old and her initial is A, and also it says Bob is 1.75 meters tall. Okay, as you can see, we don't, despite having two different print statements, we have the output in the same line. So why is that, right? So unlike other languages, C does not automatically add a new line at the end of every print statement, right? So if I say I wanted these to be on separate lines, I would do something like this, right? So you might ask me, what is this /n, right? So a /n in this case is the escape sequence for the enter button, right? So as if you look at a keyboard right now, there'll be plenty of keys which, although they exist on the keyboard, you can't actually type them. So the enter and the tab are examples of this. Okay, so when you want to represent these characters while printing stuff, we use the escape sequences to represent them, right? So there's plenty of these. There's one for like tab, space, quotes, brackets, slashes, and so on. You could honestly just look up a table and learn these if you need it, or you can just Google it when you need it. But you should just know what escape sequences are. So yeah, let's just recompile that and see what happens. As you can see, they're now on two separate lines, as compared to before. So yeah, that's kind of all there is to this, honestly. So If you have any questions, let me know. I will obviously get into the details of variable scope and memory addresses later. But for now, this is a very rudimentary understanding what a variable does and what you can do with it, which is store values and data throughout the runtime of your program. So yeah, just that's about it. Thank you.